The compact controller, you can see, it is among all of the controllers that we have to offer from the Prominent line here. Prominent started more as a pump company. We've definitely grown where controls are more and more important. Of course, Prominent Pittsburgh here, we have the piece in between there sometimes where our controller is talking to the pump, or it may need to talk to a SCADA DCS. We need to make some adaptation there, or even provide that DCS circuitry. We have that panel shop here in house. So more and more, we're becoming a one-stop shop, especially for the control side. You see the compact controller is at the bottom left there. It is our most basic controller. We do have an analyzer as well that would be maybe one step below that, our DMTA, and that is just a loop-powered transmitter, just a display, if you will. We can use that device also in place of a signal converter, or as a signal converter, I should say. So if you have a pH or an ORP sensor remote, but you want a local display, so you can have the display right where the sensor is located, or very close to where the sensor is located. You could use that DMT and then transmit the output, in a sense, of that device back to either one of our controllers or DCS SCADA system that might be supplying the voltage to them. So this time, though, we're going to talk about its one step above the compact controller. It is actually a controller. That DMT does not offer any type of control parameters, outputs, things of that nature. So the compact, it does. It is a controller. It has proportional or PID, full PID to offer for those controls. So for its price range, we'll talk about, it has a lot to offer. Now, of course, going above that, our D1CB, the wall mount is the B. The panel mount that you see in the picture there is the C. We still have those available. They will be available for the future. We do not anticipate those going away at any time. There was some speculation that those were only going to be around for a short period of time, but that is not true. That is an inexpensive offering relative to the DAC, which is one step above that, but it has limited features. So if you do need those additional features, we do need to go up to the DAC, and we're seeing very good success with that. Some of the new features that it is incorporating, and we're anticipating a lot more to come for that DAC as well. Some of the network capabilities, Profibus, CAN bus, we'll see those. We'll see wireless LAN as well as LAN offerings for that. We have some of that on the controller above there, the DDC, as we refer to it typically here at Prominent in Pittsburgh. The DDC is also the hub. It's the central point of our DOCONET. So you may see that from time to time. That's a very nice package that they've put together. So if you don't know about that, you can ask your regional and get informed about that a little bit more. But today, as we mentioned, we're going to talk about this basic controller. I don't want to call it a low-end controller because it does have a lot to offer for the price point, and of course, technology involved. We're not cutting any corners on that. So again, I'm not going to refer to it as low-end by any means. Okay. What type of controller is the compact controller? It's a transmitter. It will give us a signal output for controls, measured variables. Those measured variables currently can be either pH or ORP, referred to as redox as well. So it provides basic functions for applications. It's a controller in one direction. We'll talk a little bit more about that. Who should we sell the product to? Who should we sell that product to? And pretty much, anyone that needs controls, it might be appropriate for. But if you see at the bottom, we want to be cautious about that. We do not want to undersell ourselves. Whoever's joining us from the sales side, that return on investment, the investment of your time going out and selling things, you're going to get more from the D1C or the DAC. Of course, we don't want you to take away from that. We want to give this as an additional tool where you are competing against someone else who offers something in a lower price point. We have some examples from Europe where they have Jumo or HANA devices that we're trying to compete against. So don't take away from the markets that you've established. Those D1C sales are still very important to you. Don't undersell yourself. Get the most that you can offer. And this is for you to develop new partnerships with new customers. So definitely something else that you can have in your offerings. So the measuring ranges we have to offer for pH, of course, is 0 to 14. People tend to refer to that as 2 to 12 typically. ORP redox is minus 1,000 to positive 1,000 millivolts. Very common ranges for ORP sensors. Temperature compensation. We can offer temperature compensation for pH via a PT1000. They don't recommend you use the PT100. They're steering us towards the PT1000 for the compact controller. So that compensation range, 0 to positive 120 volts C. Of course, at above 100 volts C, we wouldn't have liquid. If we're in a water stream anyway, so be very cautious there. That might exceed the range at which that pH sensor or the ORP sensor can operate by itself. But we have a very wide range of temperature for that PT1000. The power supply for the compact controller is the universal power supply. They write that down as 90 to 253 volts, 50 or 60 hertz. They come up with that 90 to 253. That seems like a pretty specific number. That is 100 to 230 volts AC plus or minus 10% on either end. So that's how you get 90 to 253. And then, again, it's 50 or 60 hertz. We'll talk a little bit more about that on the next slide. The ambient temperature range, where it should be installed, minus 10 to positive 60 C. We'll translate that for everyone. That's not a problem. The measured variables, again, just to repeat, are pH and ORP redox, referred to as ORP. And it's switchable. In the field, you can program it to be either. So if you want to stock one on the shelf to have very quick delivery to a customer, the only thing that you don't want to stock would be that sensor. Either one of those sensors, we're not recommending that you stock. Leave that to us. Here in the winter months still, we insist that we ship those overnight, so you can have those overnighted. The enclosure rating is NEMA 6, so it's very good, very weather tight. We would still recommend, if you're putting it outdoors, to cover the unit. LCD displays, if they're left exposed to the sun, in particular, they will bleach out very readily. So please be observant of that. Dimensions very similar to the DMT. So you're just under 5.5 inches by 5 inches by about 3 inches. So it's a very small, compact unit. Go figure. Being called the compact controller. Here we're going to order it by part number. Remember, it can serve both the pH or ORP sensor. You can order that by part number 7781499, and that will include a power cord. A power cord for 115 volt single phase. Okay, that's single phase input to it. So you saw in the previous slide that it can go and accept a 230 volt as well. So if you have an application where you need it for 230 volt, just let us know. We can order that separate with a separate power cord and wire it in for you. Don't use the 7781499. We mentioned this is a very attractive price point. It's only around $900. I think list price comes up to $898. That does not include the SM6 to open-end cable or the sensor itself. So factor in for that as well. We can also mount this on a back panel for you and do some of the preliminary wiring, although there's not a lot of wiring to do, but we can include the output for you as well if you're taking advantage of that. So any way we can help you make it more attractive to the customer, let us know. We'd be happy to do that for you. As I mentioned, it is a little bit more basic. The control direction is one direction only, meaning you can select increasing pH. In that case, your pump would be feeding a caustic solution, so you're going to go up in pH, or not at the same time, or you can lower the pH by feeding an acid. Okay. For ORP, you could add an oxidant and then something to remove that oxidant. So, for example, chlorine, you can increase the chlorine reading. Of course, it's not in ppm, it's going to be in millivolt, it's going to be an ORP reading. And you can also feed, or not also feed, or feed bisulfite to remove the chlorine in that case. Okay, you can't do both of those from that same unit. You have to select one or the other. Where the D1C, really you could feed both chemicals simultaneously. It's not done very often. It's more common to feed in one direction only. So that's not really taking anything away. The only time we tend to see that really is in pH controls. Sometimes we're trying to stay in a deadband, and you'll see caustics being fed on the low end, and then acids being fed on the high end to stay in that loop. But it's kind of the exception more than the rule. As I mentioned, it does offer proportional as well as full PID controller in this very inexpensive package. One pulsing frequency output, you can use that to control your pump. One power relay output as alarm or limit or solenoid actuation. So you can select how you're going to program that unit. We have some selections on that power relay to use it as a limit or solenoid to power solenoid. We offer 1 milliamp output on this unit. It can be programmed to be either a measured value or a control output. If you don't know the difference on that, please let someone at Prominent know. Talk to your regional manager, and we can definitely help you figure that out. It also offers something that's very nice. We'll talk about the buttons on the front. But if you press the up and down arrows at the same time, if we are taking advantage of a control output, it's going to ramp the controls to their maximum. So the pulses would come out at whatever the maximum rate is that we've determined. You know, we tell it what pump we're pumping with. So if it's a gamma L pump or a beta pump, 180 strokes per minute. If it's maybe a sigma pump, the maximum speed on that might be 200, or even a delta pump can be 200. So we are able to use maybe other pumps as well that can take a pulsing signal in, or if we're controlling the pump with that milliamp signal, the 20 milliamps, it would ramp to 20 milliamps by pressing the up and down arrows simultaneously. So it's a nice way to help prime the pump, even if the pump doesn't necessarily have a prime function available. Okay, just a really quick look at the terminal strip here. You see what we're getting into more and more. We have this clamp for that coax cable that's coming from the sensor, either pH or ORP sensors. Use our SN6, and here we're going to go open end. So that open end, you'll see on the diagram that's attached, the shield, the braided shield of that coax goes under this silver clamp over here on the left. Then the center conductor, it goes into the terminal that's right in front of that. So you have the center conductor. I would connect that first, maybe. It seems easier. And then the shield would get clamped underneath this kind of thumb screw here. To the right of that, we have our jumper. We'll talk about that. That would be, we would replace that jumper if we have a reference signal. To the right of that, our PT1000 temperature sensor. We have our digital input. Remember, if we're controlling with this unit, we need to know if our sample line has stopped. The premise there is if the sample line is stopped, we're thinking that that comes off of the process. Therefore, we're thinking that the process is stopped, and we don't want to inject a chemical, continue injecting a chemical into a process line that in thought is stopped. So be cautious with that. Always include that flow switch on the DGMA or get that signal from another point in the process. So those are our inputs, and you see that the inputs are kind of below the terminal strip. Then we'll talk about the outputs, and they tend to be indicated above the terminal strip. So it's less likely to confuse that. So here, XA1, we have the milliamp output. Typically, we're going to use 4 to 20, but you can see you can scale it to be 0 to 20. And again, that can be either a measured value output or a control output. XR2 is the frequency relay. So if we're pulsing the pump, if we're running the pump in contact mode, it would be connected to 1 and 2. That would be your white wire to one of those terminals and the black brown wire to the other terminal. XR1, we'll talk about that in an upcoming slide, but that's our power relay or our alarm relay as it's defaulted to. But you know that we can change that, as I mentioned, to either limit or solenoid actuator. And then our input for the power to the far right. So the terminals are labeled pretty nice, pretty clearly, I think. It's pretty simple, pretty straightforward for programming, for knowing the inputs and the outputs. So as I mentioned, the glass sensor, whether it be pH or ORP, is connected to the clamp and the terminal in front of it. Then we have some varieties between XE3 and XE4. Here, XE3, just like we saw in the picture, is jumpered. And then we have our temperature sensor to XE4. I mentioned the reference sensor, XE3. So remember, those sensors, the pH sensor as well as the ORP sensors, are measuring millivolts, very small voltage signals. If there is any electrical noise that gets picked up in the water, which can be common, we want to use that as our 0 point, and that number is probably going to be changing. So as it changes, we need to know about it. So what we do is we run a wire into number 2, and we pick up that electrical noise that is in the processed water, or in the sample water stream anyway. We have an assembly for the DGMA, we can do that, or we can maybe clamp it to a pipe to get that signal in. But once we have that reference, now the sensor can measure a more true signal to what we need to pick up. Then again, our temperature sensor is on XE4. XK1 would be our pause input. So that is the signal coming from our flow switch in the DGMA. And then XA1 is our milliamp output. So we can have that assigned to either, again, be a measured value signal out or a control value signal. Another variation of wiring, we might see the pump going to a frequency relay. So now it's being slowed or sped up depending on where we are in relationship to our set point. Here, a variety of XR1 outputs. XR1 in this case is going to a solenoid valve. So we would use 1 and 2 to energize that, 1 being the common of that 3-pole output. Here, the center option for XR1, it's being used more as a limit relay. So we can program that limit. That limit will give you 2 different points of reference on that. So the limit will trip to a low point as well as a high point. So you don't know necessarily if you're over range or under range, but you know that that limit or your range has been exceeded one way or the other when that is actuated. If you're only going to take advantage of one of those limits, you can make the other one just to the very upper end of that measuring range to sort of eliminate it. Then finally, the third option there is the relay, where we're using it for alarm, and that alarm could be closing or opening. You see that it's sort of, in a sense, I think they refer to that as form C. So we have a common one pole that's normally open, and then one that's normally closed to that common. And then ultimately our power again on the far right. What you see on the face of the compact controller, at the top, you're going to see what parameter we've selected at either pH or ORP, and you get stickers for that when you order it. You can change it. Like I said, in the field, you can change what parameter you want it to be controlling. So you have all of those stickers available. Below that is where the display is. An up arrow, so adjusting parameters, adjusting which menu we're using. That could be the up arrow. To the right here, we're seeing more and more. It's kind of the new way that we're doing it. We have an information and a right arrow key. So information, you can toggle between what's being displayed without interrupting the operation of the unit. Likewise, if we are adjusting a parameter in the unit, maybe doing a calibration, we go to the next digit to the right by pressing that same button during that process. So that's that information right arrow button. We have an OK or an enter button. That's once we've changed the parameter to accept it or to verify that that's what we wanted to change it to, we have to hit OK. We have a down arrow, just the opposite of the up arrow right above it. Menu key, so that's helping us scroll through. Start stop key to the left at the bottom. That start stop key will start or stop the control output. So if you are using controls, if you're controlling a pump, even if that pump doesn't have some way to start and stop it, you can stop the control output by coming up to the unit and pressing the stop. An escape key, so it kind of works opposite of the OK key in a sense, where we said OK verifies that you want to accept the changes you made. If you get in a menu and you sort of get lost or you're not familiar with the changes you made and you don't want to accept them, you can hit the escape key to go back a level in the menu. We have the calibration key. That's kind of a nice feature we've been seeing on most of the new equipment. It's a shortcut to go into the calibration routine, and usually the screen is going to tell us when to hit that button next during that calibration routine. We have some LEDs. We'll talk about the LEDs here, but they're just below the digital display. We have an error LED. Comes on red if the unit is in error for any reason. Whenever units go into error, they stop the control outputs, or they set the control outputs to stop the device that we're controlling. So if we're in the 4 to 20 milliamp range, that control output would go to 4 milliamps. We have a pacing relay, so to indicate that pacing relay, or the frequency relay actually is at the bottom, that will flash at the same rate as that pacing relay is closing. So we can see that flash each time it goes out. And then the power relay is the one in the center. So if it's set for an alarm relay, it will change, it will indicate that. If it is set as a limit relay, it will indicate that for us as well. So the relays on the front are telling us what the outputs are doing. So that's very helpful. So that's really it on the compact controller. There's not a lot. We're not offering a lot on there, but at the same time, for the price range that it's in, it is offering quite a bit. So if anyone has any questions, I'd ask that you type those questions in now. Just use that GoToMeeting go to webinar toolbar, and there is a questions tab. You can type into the box there. We try to have these webinars every Friday, and we have a good history of those on prominent.us. You can just type in the search bar at the top, search field at the top, type the word videos, and you can find any of those if you've missed. At what point is temperature compensation necessary for pH? I would say that if your temperature is constant, temperature compensation isn't necessarily necessary. If the temperature changes throughout the day, maybe, an example is someone using surface water down south overnight. That pond or that pool of water can cool pretty significantly. Then throughout the day, as the sun beats on that pool, it can warm significantly different in that period of time. So when we have big temperature changes is when we definitely need temperature compensation. Hopefully that answers the question there. The max rating on the power relay, I don't know off the top of my head. I would have to guess it's 3 amps, but we'll have to confirm that. Don't take that word for it. We'll confirm that power through that relay. See what it allows us to do. Both those sensors, both the pH or ORP, as well as the temperature compensation cable, those have to be hardwired. We don't have a quick connect where we could use an SM6 to SM6 was the question. Can those use that quick connect? We don't have the quick connect to offer on the compact. Remember, we're in a very low price range, so we start adding things like that quick connect. It's a pretty pricey option relative to the overall price of the unit. So I'm sure we could help you with that, but that kind of gets away from the purpose of this unit, I think. So